Is the screen visible?
Yes, sir.
Yes, sir.
Okay. So today we'll move to another topic or next topic in mesh analysis. Okay, that is called super mesh analysis. Super mesh analysis. Okay. So what exactly this mean and why we have to look into the another aspect of mesh analysis is, before going to this point, we will let us go back to the point where we have looked into the sources. Okay. We have two types of sources, or the sources of two quantities we have in our analysis. One is voltage source, other is current source. Okay, so this is I. So when I draw the characteristic of voltage source, the VI characteristics, suppose this is I and this is V, irrespective of the current through this voltage source, the voltage will remain constant. This is V. This is ideal independent voltage source. Irrespective of the current flowing through this, my voltage will remain constant. So this source is not characterized by the current, but is characterized by the voltage. Okay. Now when I see the VI characteristics of the current source, okay, so let this be V and let this be I. Irrespective of the voltage across the current source, my current will remain constant. This is I. You can take IS, source current IS. Okay. So whatever may be the value of voltage I may be having, okay, my current is remaining same. So it is difficult to define voltage across the current source. Okay, if there is no exact voltage drop across current source in any other element. Now suppose I will take a small circuit. Now let this be 2 amperes and let this be 5 ohms. Now we know that irrespective of the potential difference in the circuit, this source will deliver 2 amperes current. And because there is only one element, there is only one loop, okay, the current will always flow in only one particular direction. And when this current of 2 amperes flow through this 5 ohm, there is a voltage drop of VR is equals to 2 into 5 is equals to 10 volts will exist. So whatever the VR I have across 5 ohms, the same VR is now existing across 2 ampere source. Now it is not difficult to find the voltage across current source. Voltage across current source is 10 volts, current given is 2 amperes. Okay. Now if I change the load resistance, now if I make it as 2 ohms, my voltage will become 4 volts. If I make it as 20 ohms, my voltage will become 40 volts. Sorry, 40 volts. Okay. So please remember one thing. The voltage drop across current source is not the characteristic of the current source, or the voltage across current source or the potential difference across current source is not the characteristic of the current source, but instead The voltage across current source is nothing but the node voltage to which that current source is connected. Now, because there is one element exactly in series or in parallel to this 2 ampere current source, if I connect in this way and I measure, it will be very easy. And please don't think that how can this VR and this VR they come in series. Always remember there is a ground connection here. Okay, this is also connected to a ground. This is also connected to a ground. Okay, so when I connect only one element across a source, that will be connected. The another terminal is as good connected to the ground. Okay, don't think that this is a series connection. How come in a series connection there are two different voltage drops? Okay, this part of the circuit it should be always present in your mind. Okay, at the back of your mind. Now, what if I will get a situation? What if I will get a situation where it is difficult to know what is the exact voltage drop across 2 ohms. Now I will yeah. So this is 2 amperes again. Let this be 1 ohm, 3 ohms. I will put one more source here. Then it will be more appropriate for the discussion. Now I will put this as say 1 volt. Let it be whatever it is. 2 ohm, 4 ohm. Okay. So now I cannot find what is the voltage across 2 amperes source directly, like I did in my previous circuit. Okay. And also I cannot use my branch current formula or current divider equation to find the current in 1 ohm, voltage drop across 1 ohm, voltage drop across 3 ohm and further, because there is one more source. So when there are multiple sources, my simple application of Ohm's law and current divider equations is not feasible. The complications will rise. So I don't know. I know what is the current in first mesh. It is 2 amperes. This is I1. Let this be I2. I1 and I2. Now I know what is I1. It is 2 amperes because I1 is flowing here. I hope you have gone through the examples that I have shared you few days back, in which I covered this aspect, where the current source is existing in the perimeter of a mesh, and that part of the mesh is not common to any other mesh. If current source exists in the perimeter of the mesh, which is not common to any other meshes, that mesh current is equal to that current source. So I1 is equals to 2 amperes. But what about I2? I can't get I2 until I write a voltage equation. That is KVL. Okay, this is evident. Until I write KVL equation for mesh 2 and substitute the value for I1 in that, I can't get the value of I2. Now this is very simply solvable by using our KVL equations, mesh or normal mesh analysis. But you want to get the voltage across 2 amperes, first I should know what are the currents through the elements. But mesh analysis is about knowing the currents through voltage drops. Now I will give you one situation where a current source will come in common between two meshes. Okay. So let this be 10 volts. Let this be 5 ohms, 8 ohms, and 12 volts. We will take it from directly the example. Now, It is evident that I have two meshes. Okay. Let this be I1. Let this be I2. Now let the value of the current is say 5 amperes. Now I want to write the voltage equation for mesh 1 or KVL equation for mesh 1. Very conveniently I can write plus 10 volts minus 5 into I1. What about this 5 amperes? Because in KVL equation there should be only the either EMF values or drop values. So across this 5 amperes, I don't know what is the EMF also, I don't know what is drop also. Then application of KVL in normal way becomes invalid in such cases. I cannot apply KVL independent to mesh 1, KVL independent to mesh 2. Okay. This is the problem, because this problem we never came across before. We never saw an example where current source was common between two meshes. Right? Okay. When current source come in common between two meshes, normal mesh current analysis is not valid. Valid in the sense it will create a lot of complications. So what is the possibility is that now I can define a arbitrary voltage across 5 ampere source, say some Vx or Vy or V1 or V2, whatever. Then apply KVL to that mesh, apply KVL to mesh 2, then solve it. But this type of analysis will increase complexity if the number of meshes increase. Okay. Second method is to define a super mesh. Second method is to define a super mesh. Now what super mesh is? Super mesh is nothing but combination of meshes. Okay. Super mesh is combining the meshes that have current source as common element between meshes. Common element between those meshes. Okay. And writing KVL equation to bigger mesh considering the respective currents or respective mesh currents in each element. Now, what is the mesh current in 10 volts? Is I1. What is the mesh current in 5 ohms? Is I1. What is the mesh current in 8 ohms? Is I1. I2. What is the mesh current in 12 volts? Is I2. Okay. So when I write KVL, I will tell you what does it mean. Okay. When I write the KVL equation for the bigger mesh is known as super mesh. Okay. When I write the KVL equation for bigger mesh or super mesh, in each element I should be considering the respective current. If I'm writing the drop across 5 ohm, the drop across 5 ohm will be 5 into I1. If I want to write drop across 8 ohm, the drop across 8 ohm is 8 into I2. Though these both will come in the same equation. Okay. So how it can be done? Okay. Now I know what is super mesh. Why the super mesh has to be considered? Okay. This condition will arise when I have a common current source between two meshes. Then I should be combining these two meshes. Okay. So let me give a name here: A, B, C, D, E, and F. Now I have two meshes. Mesh 1 is ABEFA and mesh 2 BCDEB. Now when I combine these two meshes, it will become only one mesh. Okay. So how to do that? How to combine? Now I know when there is a current source common between two meshes, I should combine these two meshes and write the KVL equations for the bigger mesh, KVL equation for the bigger mesh, considering the respective mesh currents. Then how to do that? This is done by ignoring the current source. Okay. The two meshes that have common current source can be combined and made super mesh by temporarily ignoring see, please remember, I am writing temporarily ignoring, not neglecting. Neglecting is different, ignoring is different. Okay. Ignoring means the element is there, but I am not considering for a moment. Neglecting means permanently I am taking out that from the picture. So I am not neglecting it, I am ignoring it. Okay. I made super mesh by temporarily ignoring the current source, the common current source. It is applicable only for the common current source. Okay. The two meshes that have common current source can be combined and made super mesh by temporarily ignoring the common current source. Okay. Now I will redraw the circuit. So this was A, B, C, D, E, F. Okay. What are the values? 5, 8, 10, 12. Sorry. Okay. So now I am temporarily ignoring the current source. So I will draw that with a dotted line. This is 5 amperes towards up. Okay. Now, for a moment, I will write the small mesh I1 and mesh I2. Okay. So now I want to create a super mesh. Okay. So mesh 1 is ABEFA, mesh 2 is BCDEB. Now if I ignore this 5 ampere current source for a moment, then the dotted line indicates this is not into picture right now, but it is there in the circuit. Okay. Now this is from A, B, C, D, E, F, A. Now this is one combined larger mesh called super mesh. This is super mesh. This is a super mesh. Now what is this super mesh is? Okay, this super mesh is A, B, C, D, E, F. Now to analyze this kind of circuit where current source is common between two meshes, I take the help of super mesh method of analysis and write the KVL equation. Now let us write the KVL equation for super mesh. See, when I get this kind of problem, I will not be applying individual KVL equations if that particular mesh is combined or is having a common current source. If a current source is existing in the perimeter of the mesh, like I shown in the example here. Now this current source is existing in the perimeter of mesh 1 and is not common to any other meshes. Therefore, analysis is very easy because readily I will get one mesh current, that is 2 amperes. Only thing is that I have to apply KVL for mesh 2, substitute value of I1 into that. Okay, if I want to solve this, I will solve. I1 is equals to 2 amperes because direction of I1 and direction of 2 amperes is same. So it is I1 is equal to 2 amperes. Now suppose this 2 ampere current was downward, then I1 would have been equals to minus 2 amperes. That's it. Okay. Now write KVL equation for mesh 2. So what I get for KVL equation for mesh 2 is minus 3 I1 plus 2 plus 3, 5 plus 4, 9 I2 is equals to minus 1 volts because current and voltage are opposing. Now I need not to solve simultaneous equations here because I know the value of I1. Now put the value of I1 equal to 2 amperes. This will be minus 3 into 2 plus 9 I2 is equals to minus 1. Okay. So 9 I2 is equals to plus 5 because plus 6 minus 1 or I2 is equals to 5 by 9. So this is very easy solution when the current source is existing in the perimeter of this mesh and that current source is not common to any other meshes. Now if there is one more mesh, I would have written another KVL equation for that mesh and solved only two simultaneous equations in terms of I2 and I3. Okay. So that can be done very easily. But the complications arise when the current source exists in between two meshes as a common element. The problem with this kind of analysis is that I cannot define the voltage across 5 ampere source. That is the biggest problem. I can define and I can do that assuming some voltage, but that increases the complexity in the analysis. Okay. Now applying KVL to super mesh. So here we will do apply KVL to super mesh. Okay, super mesh A, B, C, D, E, F, A. Yeah. Now before applying KVL, I should mark the current. Now both I1 and I2 are in clockwise direction. So I assume that super mesh is also to be traced in clockwise direction. So with that direction of current, or with the direction of I1 in 5 amps. See, please remember, super mesh is not an additional current. Please don't think that there is one more current coming to picture because of super mesh. No. I have to consider the respective mesh currents. This is extremely important. I have to write the KVL equation to bigger mesh or super mesh. KVL equation for super mesh by considering the respective mesh current in each element. So the mesh current in 5 ohms is I1. The mesh current in 8 ohms is I2. So only I have written smaller I1 and I2 so that we'll recognize it quickly. So I1 is flowing in clockwise direction. The polarity will be this way, passive polarity or passive sign convention. I2 is flowing in clockwise direction. Polarity across 8 ohms is in this way. Now, simply apply KVL from A to A following A, B, C, D, E, F, A points. That's it. And equate it to 0. Okay. Okay. So, now apply KVL to super mesh. From A to B, the resistance is 5 ohm. Current through 5 ohm is I1. Okay. So that is minus 5 into I1. Then from A to B, then B to C, minus 8 into I2, because current in 8 ohm is I2, current in 5 ohm is I1. If there would have been another resistors, then across them we should be taking the respective mesh currents. In further examples, you will get to know. Okay. Then I2 is flowing in 12 volts. The direction of I2 and direction of 12 volts is opposite. Okay. It is fall in potential. So therefore minus 12. Then from D to E, no element, E to F, no element, from F to A, voltage 10 volt voltage source. The direction of voltage source and the direction of current both are same, so it is plus 10. That is rise in potential. We are experiencing rise in potential equals to 0. Okay, so by rewriting this, what I will get? If I take this 12 minus 12 plus 10, it is minus 2. What I can get is 5I1 plus 8I2 is equals to plus 2. Now this is equation 1.
Sir, is equal to minus 2.
No, it will be plus 2. Minus 5I1 minus 8I2 minus 2. Oh, sorry. Is equal to minus 2. Sorry. 5I1 plus 8I2 equal to minus 2. Now the problem is, I have one equation and I have two unknowns. How to solve this? We can't solve this. But we haven't yet finished considering the equations. There is one more equation that will come into picture. What is this 5 amperes? Is the current between mesh 1 and mesh 2. And when we started looking into the mesh analysis, we have seen that the current in common element between any two meshes is the algebraic sum of or the resultant of two mesh currents. Is it? So now 5 amperes is either I1 minus I2 or I2 minus I1. Do you agree?
Yes, sir.
Between B to E, in the branch BE, current I1 is also existing, current I2 is also existing, because that is a mesh current. I1 and I2 are mesh currents. So mesh current I1 has to flow through 10 volts, 5 ohms and 5 amps. I2 has to flow through 12 volts, 8 ohms and 5 amps. So this 5 amps is the resultant of two mesh currents I1 and I2. Okay. Now by observing the direction of current source and the direction of mesh currents, the 5 ampere is the direction of I2. Is it? 5 amperes is in the direction of I2. Now you can write it here. The current source five amperes is resultant of I1 and I2, because uh, 5 amperes is common to both meshes, because 5 ampere is common to both meshes, and it carries and or 5 amperes is in branch, okay, that is common to both meshes, and it carries or and this branch carries and this branch carries both mesh currents. This branch carries both mesh currents. So therefore, uh, or before this, 5 ampere is in direction of I2. Therefore, I2 minus I1 is equals to 5. Now this is equation 2. I2 minus I1 is equals to 5. Now can we solve these two equations? Or
Yes, sir.
minus I1 plus I2 is equals to 5. This is equation 2. Okay. Either you can use back substitution method. You can take I2 is equals to 5 plus I1, substitute in this. I will get only one equation in I1 and you can solve this. I will do the same thing here. Let us not use calculator for the simple calculations. So I2 is equals to, it is 5 plus I1. Okay. Now this you substituting equation 1. That is 5I1 plus 8 into 5 plus I1 is equals to minus 2. Okay. It is 5I1 plus 8 5s are 40 plus 8I1 is equals to minus 2. So it is 13I1 is equals to minus 42. Therefore, I1 is equals to minus 3 point some 2 3. Yes, amperes. Yeah, 3.2307. Okay. Now I1 is, sorry, yeah, I1 is minus 3.23 amperes. Now what is I2? Okay. Now this you substitute in equation 2. Okay, that is I2 or equation 2 is minus I1 plus I2. Now, minus of minus 3.23. See, whenever we are substituting the current values, please use the signs also. Okay. Plus I2 is equals to 5. Therefore, I2 is equals to
1.77.
okay, 1.77 amperes. So I2, that 5 amperes is nothing but I1 plus I2. Is it? 1.77 plus 3.23 is exactly equal to 5. This is how we have to solve the mesh analysis, okay, using the super mesh method. Why super mesh will come into picture? Super mesh will come into picture because there may be a current source that is existing in common between two meshes. Current source that is existing between two meshes. With this, only with this reason, I have to go for super mesh analysis. If not, then I can go directly with normal mesh analysis. So please remember that in the exam or anywhere, you will not be given separately stating that solve this following example using super mesh analysis. You have to recognize the circuit. What is the circuit orientation? If there are any current sources in parallel to the uh, in between two meshes, then you should be knowing that it has to be solved through super mesh analysis only. Okay. Any doubts? Any clarifications? Any confusions? Any doubts?
No, sir.
Yes. Anybody else? Okay. Any doubts so far? Others? Others, are you there? Only
Yes, sir. No doubt, sir.
Yes, sir. Good out, sir.
21 people are absent today. Okay, so please remember that we are not neglecting the current source. We are simply ignoring temporarily. While writing super mesh equations, we ignore. Okay, while writing super mesh equation, we ignore, but we don't ignore or neglect that forever, because that current relation I need to solve further. Okay, so the common current source, whatever I get between two meshes, is the resultant current of those two meshes between which this current source is common. Okay, so therefore I have to consider that as equation. So one equation will be for super mesh, another equation will be for the current source. Suppose there is one more loop or one more mesh, then I can independently apply KVL equation to third mesh. If there is no common element again, then I can write. Okay. Now suppose in another example. Now let me take this circuit. The same circuit I will extend. Now this was 10 volts, this was 5 ohm, this was 8 ohm, this was 5 amperes, this was 12 volts. Let me take this as 12 ohms and 15 ohms. It will come as 12 plus 15. Okay, but just to understand. Now, what will be the super mesh? A, B, C, D, F, G, and H. So let this be I1, I2, I3, because we know there are three meshes. Okay, and there is a current source between mesh 1 and mesh 2. So therefore I have to neglect this, or sorry, ignore this for a moment. then I have to write a super mesh. Okay, I should be having a super mesh here. Okay. Oh, mesh 1 A B G H A, mesh 2 B C F G B, mesh 3 C D E F A. Okay. Now because we have common current source between mesh 1 and mesh 2. Okay. Therefore, we combine them and form a super mesh. Okay. So what super mesh is? It is A, B, C, F, G, H. Okay. Now this is the super mesh. Now, what I can do is now apply KVL to super mesh. Okay, apply KVL to super mesh. So current I1 is clockwise. So this is the case. Current I2 is clockwise. This is the case. Current I3 is clockwise. These are the polarities. Okay. Now apply KVL to super mesh. Now I have to get three equations. Is it? There are three meshes, three equations. There is no doubt in that. Okay. Equation will be for super mesh. One equation will be for this independent mesh. One equation will be for this current source. So three equations. Again, we will solve with three equations. Now apply KVL to super mesh. The same equation as of previous example we will get. Okay. Minus 5I1 minus 8I2 minus 12 plus 10 is equals to 0. So I get plus 5I1 plus 8I2 is equals to minus 2. This is equation 1. Okay. This is equation 1. Now, second equation. Okay. For current source, which is common between two meshes, for current source it is I2 minus I1 is equals to 5. This is equation 2. Now I have I3 also in the picture, so I should be applying KVL to third mesh independently. Okay, then apply KVL to mesh 3. Okay, apply KVL to mesh 3. So the super mesh is A, B, C, F, G, H, A. Apply KVL to mesh 3. What is that mesh 3? C, D, E, F, A. Okay, so that comes out to be plus 12. Direction of current and direction of current and direction of 12 volts is same. Plus 12 minus 12 I3 minus 15 I3. Okay, minus 12I3 minus 15I3 is equals to 0. So from equation 3, I can get I3 directly. It is 12 minus 27I3 is equals to 0, or I3 is equals to 12 by 27 is equals to 0.44. Sorry, 0.44 amperes. Now I3 I got, see, this happened because there is no resistor in series with 12 volts. If there would have been resistor in series with 12 volts in mesh 3 equation, I will put a, let it be, okay, 2 ohms. Okay, so let me rewrite the equation. So it is plus 12, okay, minus this current I3 is flowing through 2 ohms with this polarity plus and minus. So minus 2 into I3 minus I2. Minus 2 into I3 minus I2 minus 15 I3 minus 12 I3 is equals to 0. Now rearrange this. 12 minus 2 I3 minus 27 I3, that is minus 29 I3 plus 2 I2 is equals to 0. Okay, so always write KVL equation in such a way that if you are writing for mesh 1, the coefficient of I1 should be positive, coefficient of I2 and I3 should be negative. If you are writing for mesh 2, for I2 it should be positive, I1, I3 should be negative. For I3, for mesh 3, I3 should be positive, because it is very easy to verify that equation using inspection method. Okay, so I will write this as minus 2I2 plus 29I3 is equals to 12. Now this is equation 3. Okay, now solving equation 1, 2 and 3. Okay, now solving those three equations. So equation 1 is 5I1 plus 8I2. A2 minus 1, 1, 0, 0, minus 2, 29, 12. It is I1 is minus 0.15. Getting the same, or you are not doing it? I2 is minus 0.15. No, it should not be. Somewhere mistake we might have done. I3 is 0.4. It should not be like this, because I1, I2 minus I1 should be 5 amperes. It is coming as 0.3 amperes. Or sorry, 0. I think maybe some mistake in substitution at my end. Okay.
Sir.
A2 as minus S5. Yeah. I1 as minus 3.2, I2 as 1.76. Sorry, there was a small mistake in substitution. I1 as minus 3.2. Okay. I2 as plus 1.76. Same values 3.23 and 1.77. I3 as 0.53. Okay, amperes. Now, okay. Now what is the current value? I2 minus I1 is equal to 5. Now substitute I2 and I1. I2 minus of 1.76 minus of minus 3.2. It will come around 4.99 or so. 4.96. If I consider all the decimal points, it will come as 5. So this is how we have to find this solution for the circuits which contain the current sources common between two meshes. Okay. So in next class, we'll solve a few more examples on this. Okay. If possible, I will be forwarding you the solved examples also. Okay. Then we will end up this point, this part, and we will take next this node voltage analysis. Any doubts so far?
No, sir.